when you look at the parts of a camera, there's an awful lot of things that can control or have an effect on your exposure. And the exposure is the amount of brightness or darkness in your image, and it depends on a lot of different factors. First of all, there's, how bright is the actual scene? Is it under moonlight, or are you under spotlights, or the midday sun? So the amount of light that's in the actual scene is going to have a huge impact on what your exposure is. But then there's several mechanical processes throughout the camera system that we saw that will actually be able to reduce the amount of light or let more light in, so that you can recreate the image sort of the way that you want to. And a lot of times that's a stylistic decision as to whether you want it to be kind of dark and moody or bright and open. But a lot of those things combine with the actual lighting that is in the real world. So I'd say the number one control of your exposure is actually the light itself in the scene. If you're just going to shoot on automatic on your camera, then if you want to take a bright picture, then you go into a bright place. And if you want to shoot something that looks more dark and moody, then you shoot it in a dark place. But we're not going to use the automatic mode because we're professionals, and then we do things the professional way. So why do we care about exposure? We as filmmakers need to show the audience what we want them to see. And unfortunately, the camera just cannot see everything. The real world has a huge amount of difference between the darkest things in the world and the brightest things in the world. So here, you've got a shadow in a cave and it's super dark. There's zero amount of light there. And here's the sun looking straight into it. It's super, super bright. And there's lots of different ways to measure this, lumens and foot candles and all that fun stuff. But the fact of the matter is that this is how much light there is in a given place. And in the real world, in the universe, it can span just ridiculous amounts of light. And a camera has a limitation. So we compare that to what we can see, right? Because this is what we're used to, and this is ultimately what we're going to be working with, is what the audience sees. We can't see this huge difference, and this is why we have an iris in our eye. So we can see, maybe about this much. And anything that's darker than the bottom of our vision just becomes completely black. We don't see any difference in this part. Even though there's less light here and more light there, it's all black to us. And at the same time, once you get past the range of our vision, all of this stuff is equally bright white. We can't see any more detail in that because we just don't have the capability. So the iris in our eye actually opens and closes so that we can move up and down this scale. And to relate this to cinema, when you go see a movie and you're sitting in a dark room for a couple of hours, your eye opens wide up to let a lot of light in, so that you can see the movie pretty well. But then when you go outside, you're like, oh my God, Armageddon, because your eye hasn't adjusted to the outside, so it's letting in way too much light. Your eye has adjusted to sort of this top level of the spectrum, so that you're seeing that amount of light coming in, and it's like, oh, that's crappy. You need to shunt that down so that you're back to cutting out some of that bright light. So that's what your iris does in your eye, and that's what the iris in the camera does as well, along with all the other things that we have to do to control it. And here is where things get a lot of fun, because for a camera, depending on whether it's film or video, both of those see a lot less than the human eye does even. So if we are thinking about how much of this range a camera can see, it's probably more like this. It's probably less than half. Probably the math on that is beyond me. Fractions, I know, who knows how to deal with that. But it's significantly less than what you can see even. So whereas, our bodies are choosing, and our bodies and brains are choosing which portion of the real world brightness level, which is, we call this dynamic range or contrast ratio. The amount of difference between the darkest thing and the brightest thing. So, we have a pretty wide range. This area in here is our dynamic range at any given time. And for the camera, whoa, file requester, we have much less range. Our box is smaller to slide up and down this spectrum of dark to bright. So what we have to do then in order to recreate, what people are used to seeing, we have to take a lot of care in placing this sensitive area on the scale of dark to light. So telling the camera which part of the image should be visible and have a lot of detail in it, and which parts is it okay to say, okay, that's all going to be white because it's super bright, overexposed, and which parts are okay to say, you know what, that's black, and everything darker than that will be black. So that's how that basically works, is we're choosing what the audience is going to see. So this can be both a mechanical thing where it's just, the difference between it being completely too dark to see and completely too bright to see, and finding that nice middle ground so you can actually see things. But it also becomes a very big artistic tool so that you can set the mood and the tone. So if you want, sort of a happy, positive kind of image like they do with most sitcoms, you're going to have a pretty bright exposure, and everything's going to be sort of above the midline of your exposure. And if you want to have sort of a film noir thing going on, then you're going to have really dark shadows, and most of your stuff is going to be sort of below the midline. So this is not just a mechanical process. This is also a very big part of creativity and the creative tool, and directors and especially cinematographers deal with this all the time. So anyway, how does this work? Once we know that, okay, we have to deal with the exposure, how do we actually control that? And like I was saying, the light source that you're working with has a huge impact on this. The sun, obviously, super bright, so you're going to have to, and you can't change it. You can't tell the sun, would you kindly please turn yourself down just a tad, maybe move a bit further out. It's not going to listen. So if you're shooting with natural light and that's the sun, then you just kind of have to deal with it all within your camera. If you're to the point where you can set up film lights, then you can take more control over where these are and how bright they are to kind of create your own lighting setup. So that's a big part of it. The existing light is a huge part of getting your exposure correct. Your first line of control with your camera is going to be called neutral density. In the front or the back of your lens, we have a piece of dark glass. In our camera, this comes behind the lens, that is going to cut down on the amount of light that is allowed to pass through to the image sensor. This basically works exactly the same way that sunglasses work for people, by just using a dark piece of glass to knock the amount of light down. And what we actually have on our cameras, in the video cameras, is a couple of varieties, so we can spin those into place, and we have a low, medium, and high option to do very coarse changes to how much light is coming in. You don't have a lot of fine control with this. This is meant really to do the difference between a big, bright, outdoor, sunlit scene versus something that's going to be, lit by, candlelight. You would use this wide open to shoot, a candlelit scene, and you would use it with the super dark setting for using the sun and blocking that amount out. So that's what your neutral density filter lets you do, is take that first pass at controlling the amount of light that's going to come into the camera. And then you've got your iris. And the iris is the primary tool that you're going to use to deal with your amount of light that's going to let in. This is the hole that you can change the size of that allows a certain amount of light into your camera. We always refer to the size of that hole as the aperture. So what does that do for us? Well, it basically is like a very fine-tuned instrument where you can say, I want this much light, or no, half of that much light, no, actually half of that. So that's what it's measured in. It's measured in halves. Everything is either half or it's times 2 in the other direction. So it's really easy to know how much light is coming in at any particular setting with the iris. And it's measured in something called f-stops. So you're going to see a series of numbers that are reflecting the size of this hole and the amount of lights that's coming into it. So you've got a series of 1.4, 2, 2.8, 4, 5.6, 8, 11, 16, 22. So all of these have little f's in front of them. F1.4, F2, F7.8, F4 down the line. So those are called f-stops, and that is a series of numbers that tell you which setting has twice as much as the previous. So every one of these is a halving of the amount of light that comes in. And what's confusing about this is that the larger numbers actually let less light in. So let's take a look at this in detail. We're just going to take a small subsampling of it. We're going to call it our f value is f over 4, and we're going to jump to f over 8 and f over 22. That's actually how this is measured. So an f4 means that your aperture is pretty big. A lot of cameras can go to a smaller number than 4, which means a bigger hole than 4. But that's pretty much the on the wide open end. F8 is going to be a much smaller opening, and so that's what the light's going to come in. And an F22 is just going to be a little pinprick that's going to let a tiny amount of light in. So this is what your iris looks like at an f4. This is what your iris looks like at an f8, and what your iris looks like at an f22. So this is going to give you this is very bright. There's a lot of light that can come in through that giant hole. And this is obviously going to be very dark. You're not letting hardly any light in at all. So why would you use these? If you are, again, inside in a dark environment, you need to let more light into it. So that's when you would use something like an f4, a very small number to let a lot of light in. If you have a lot of light in your image, you're outside under the sun, then you're going to want to use a much smaller opening, which means a much larger number. Now, just briefly, the reason that these numbers are like this is actually a fraction. F over 8 means the focal length of the lens divided by 8 is how big the hole is. So they're the denominator of a fraction, so that's why when they get bigger, the hole gets smaller. So if that helps you with the mnemonic aspect of it. And another thing, if we look at the full series where it's 2, 2.8, 4, 5.6, 8, 11. In that series, as these are marked, like I said before, these are powers of 2 that these represent. So if this is, just assume that this is, 1 exposure, then this is going to be half as much light. This is going to be a quarter of the light. This is going to be the 1/8 of the amount of light, 1/16, 1/32. So every time you move to one number bigger on your f-stop chain, you're letting in half as much light, and vice versa. This is twice as much, twice as much, twice as much, twice as much, twice as much. So it's really actually easy, even though the numbers that they use to measure them in the f-stops are strange, the actual baseline of understanding how much light is coming in is very easy, because every stop is either half or twice as much light. And so that makes it kind of easy to do the other calculations that you need to do. So again, the reason that you do this is so you can recreate the image the way that you want to, so you can control that people can actually see the thing in the first place, and then have fine control over the way it looks, dark or light. And specifically, if you have a lot of different things in your frame, that some things are brighter than the others, you got to tell the camera which thing you want to see. So instead of exposing for the dark window that has nothing behind it, or the bright lamp that's in the middle of your shot, you want to expose for the face of the person sitting in the middle of the room. So, you know, if there's a light over here and a dark window, those are all going to be very different sort of brightness levels. If we expose for the light bulb so that you can see the filament inside of it, then all the rest of this is going to go black. If you expose so that you can see what's outside the dark window, then it's going to let in so much light that everything else here is going to go to white and you won't be able to see it. But 9 times out of 10, what you really want to see is the person that's in your scene. So when in doubt, set your exposure based off of what makes the person look good, and then work with the other stuff as needed. So if you expose for his face and then you still need to see out the window, then you need to put more light out there. Or if you expose for this face and you still need to see the light, then you've got to make the light a lot dimmer. So your subject is going to be the thing that drives your decision of how to expose. And obviously in this scenario, he's going to have a bright side of the face and sort of a shadow side of the face. So even at that point, you're going to decide, okay, which side of his face do I want to expose for? And that's where you get to use your creativity. You say, oh, do I want him to have a shadow on his face? Do I not want him to have a shadow on his face? Does the whole thing need to be bright? And that's where the whole aspect of lighting comes into play. So we'll get into that in further classes, but just remember that, it can be a complicated topic, but really, in the end, what you're deciding is what your subject looks like for the people who are watching it at the end of the chain.